Next, we're going to be dealing with the floor over an unconditioned area, and specifically a cantilevered floor here. Before we insulate it though, we have to set up a ladder, and it's important that although we may want to hurry and get our insulating done, it's important to set up a safe work environment. So before I do that, I want to make sure that I'm working on a level area and that I'm also working with a ladder that's rated for the work I'm going to be doing. Now dealing with the insulation portion of rooms and floors over unconditioned areas, including cantilevers, which is what we're looking at right here. I want to make a quick point about safety. When you're dealing with fiberglass or cellulose or spray foam, it's important that you're using the right safety precautions, which in this specific case, dealing with fiberglass insulation, is I'm wearing gloves and safety goggles. The most important part, instead of necessarily dealing with the R value, is the concept of when I'm looking in this floor over an unconditioned area or a cantilever, is that I get full six-sided contact with whatever insulation I use. So if I'm using bad insulation, which can be the hardest to fit in an area, I have to make sure and cut it to where it's going to have contact with my floor above, whatever my finished product is down here, and then each side of my floor cavity. That is the #1 mistake that's made when people insulate these areas, and why you've probably experienced a cold room over a garage, a cold bonus room, or any kind of floor that hangs out over your house. You've experienced cold floors in there. It's because they're not insulated and they're not air sealed properly. So if I'm using a fiberglass bat in this situation, a common mistake people will make is they'll actually take the fiberglass bat, put it in this cavity and staple it to the bottom of this floor joist. But there's no contact between the insulation and the floor above it. And with insulation, it's meant to restrict heat leaving a conditioned area. So I have heat leaving my floor before it ever meets insulation, and that's why so many of those areas are so cold, both because it doesn't have contact with the insulation and it's not properly air sealed. Assuming in this instance that you're going to use fiberglass insulation, when you're installing it, a quick point to make is that you have no compressions. Very typical problem is people will take it and think it's doing a good job by smashing it up in there. The ability of fiberglass to resist heat loss is actually when it's nice and fluffed out like it is. We can rely on whatever material we use, whether aluminum or vinyl soffit or any kind of board underneath here to push this up. That'll actually hold the insulation in place. What that'll also do is ensure that we have, again, full six-sided contact when I put my underlayment here in place, that we don't have that issue. Moving then from minimum then to best is, since we already have full six-sided cavity insulation contact up here, to get to the best category would then be to install, before we put our soffit material underneath here, is a 2-inch R10 foam board underneath here. And what that's going to do is that's going to prevent thermal bridging between my floor up here, my floor joist down here, and then the outside. We're connected with insulation where I have contact between my insulation and my foam board in these areas, but every 12 to 16 inches where I have a floor joist, I'm losing heat from my floor down through this floor joist and the outside when I don't have a thermal break that prevents this thermal bridging.